Okay, good morning everyone. So today we are going to talk about the particle system. So first things, let's take a look about the final result. So here is the final animation. For sure, probably for the scene design and also the environment design, we are not going to do too many details. But we will go through the overview and let you guys know how the particle system works. Okay, so that's the final animation. Let's take a look. So first thing for sure, we are going to use particle system to generate the butterfly and use a force to force all these butterfly flying. And also we are going to use some modifier to create this kind of dissolve effect and so that you can see your sculpture will gradually dissolve and be turned into particle. That's the effect we want to do. And final thing is that we have some grace on the ground. For this part, actually, I don't like using this way to do the grace. But also, I will show you how to do that because it's also related to particle system. Okay, so that's the things. So let's open up a new file and start to working on our project. Okay, so first of all, let's talk about some basic setting for the particle system. How can we generate the particle system? Usually we can just simply add a geometry and then make the geometry become the emitter. And this emitter will start to emit the particle. Let's take a look. So I will wipe out and temporarily hide all the things right here. Or you can just simply turn off the collections. It doesn't matter. So usually I prefer you guys work in the world center. So let's press Shift and S, and move the cursor to world origin. So now let's choosing Add, Mesh, and choosing a UV or icosphere. For this time I will choose UV sphere. So now we have a little sphere. How can we add a particle system? Basically, particle system is just like there are thousands of little phantom or little dots, and it will flow in the air. And you can use in forces to affect how they move or how they act. So first of all, we have to create an emitter. So let's choose this sphere and then go to the particle and click this plus button, and now we will have the particle. If you press play, well, the particle show up. So that's the basic setting. But right now the particle just keep falling down, right? The particle just keep falling down. So how can we change the direction and how can we change the movement of the particle? Then it will be about the forces. So in order to make this particle can move in a different way, we have to add a forces inside your Blender file. So let's go to here, Physics, Force Field. And we can choose different type of force. Once you choose force field, it will automatically generate new forces in the world center, or let's say in the cursor. But if you don't like it this way, for example, I think this is not very intuitive. It just directly generates forces. So that's not the things I want. Let's press delete the forces, or you can just simply uncheck this one. And also, because right now we're using this sphere, so it will also generate the forces on this sphere. So I think it's not a very good way for manipulate. So let's press Shift A, or let's go to Add and choose Force Field. And you can choose different type of force right here. So probably I want to use force That's the same. But right now you can see that we can move his force away. So now let's take a look. Alright, still falling down. But if I make this one go get closer, well, it doesn't have any difference. Because right now the force is too weak. Let's increase the number. So now you can see, we can use this force to blow the particle away. Just like this. Okay? So I would say that's the basic particle system setting. First thing, we need to have an emitter. Second thing, we need to have forces. So we can use these two things to interact with each other. So for the next part, we are going to talk about how to change the detailed parameter setting inside the particle system and also the forces. Okay, so now let's take a look at some detail about the particle system. So for the first one, if I want to assign a certain point and only allow this point to emit the particle, how can we do that? If we want to do that, first thing, let's go back to our model and I will turn off my example first. So that's the things we have. If we want to make probably the top vertex to emit the particle, first thing is we have to go to edit mode, and choosing the vertex you want to use. So for example, I want to use this vertex. I don't want to use this 4, so let's press Ctrl and using frame selection to deselect this part. And now let's go to data. Go to the vertex group, create a new group, and don't forget to choose assign. Once you have, then we go to the particle again, and the emit you can choose in vertex or choosing faces. I think vertex will be fine. Then scroll down. For the density part, let's choose in the group. So now let's see what kind of thing will happen. You can see that right now the particle only show up on the top faces. If I press play, well, now it worked. And we can use this one to interact with the particle. Okay, so that's how it works. So now let's talk about some basic setting about how to emit the particle. So first things, let's go to the particle system and then let's go to the particle section to check the setting. For the emission part, it will be the basic setting about the particle itself. For example, how many particles you want to have, you can increase the number right here. So for example, if I want more, then probably turn into 3000. And you can see that now it becomes much more dense. And second thing for the seed, it's about the randomness. Okay, it will control the different randomized result about how the particle movement and the particle number in every second. So if we increase this number, probably let's turn this one into 100. Let's play again. You can see that it becomes a little bit different, right? If I decrease this number, well, things will become much more regular. So see, that's the regular pattern, and if you increase this one, it will change the random result, change your particle movement and make them become much more random. And the frame start and the end time, that's very, very important. So if you want to make the particle keep emitting from the very beginning to the end, then we can change your number right here. So for example, we can make the particle emit before our animation start. Our animation start from frame 1 to frame 250. So if you want this particle can emit earlier, let's type in probably -10. So it will start to emit before the animation start. Also, if you want the particle emit until the very end, let's type in 250, or you can type even more, probably 270. So now let's say, okay, it will keep emitting and then keep continue emitting and until the end of the animations. Also for the lifetime, it tells you how long will the particle exist on your screen. If you make them their lifetime very short, probably only 5 seconds, let's see, okay, because they only exist 5 seconds. So once they go to here, they will disappear, right? So that's how the things work. Let me delete the keyframe. So if you want to make your particle can exist forever, but somehow it will largely increase the loading of your laptop because they will exist for a very long time. But we can try. Let's change the lifetime into 250, so which means the particle will exist for the entire animation. So let's say before that, display. Before that, if we change the particle system lifetime short, only one, okay, you can see it only exists right here. But if we start to increase, okay, they will move more longer and longer because they will have more lifetime and so they can run very far away. So that's how it works. Now let me wipe out this one. Otherwise, you will increase my loading. Alright, so that's the basic thinking. And lifetime randomness. It's just like the random seed. For the random seed, it will offset the number table, which means sometimes it will increase the number of the particles and sometimes it will decrease the number of particles. But for the average, it will still be 3000. And for the lifetime randomness, it will also offset and a lifetime table. So sometimes make this one shorter, sometimes make this one longer. So let's see. Some of the particles will have a longer existing time, but some of them probably will have a shorter existing lifetime. So that's the functions of the lifetime randomness. Alright, I will give this one 1. I like the randomness. So that's the basic thinking about the particle system emission part. So you can try to play around with all these parameters and in order to find the best result. Okay, so now we have already finished the emission table explanations. So for the next part, the things we are going to do is velocity. So to give you a very important idea, you guys don't have to go through all the detail of these sections because there are too many things inside. So we just need to know the most important part, and it will be emission, catching, velocity, rotation, physics, render, and also children and the field wave. I think this part is more important than the others. So now let's go to the second one. For the catches, we can do that later. So how about what's the meaning of velocity? Basically, I think for this part it's very clear. For the normal speed, it will create a speed and force based on the normal direction of various forces. So for example, right now our particle emits from the top vertex, so it will base on the top vertex normal direction to create the forces. So if I increase the number right here, you can see, oh, it go up because it becomes the force between this one, and because we have a forces right here, and we also have a normal forces right here, so it becomes somehow we can use in the vector addition to calculate how these two work. So this direction, that's the move direction of this particle. So let's praise. So see, that's how it works. And for sure, if we still keep increasing the power, the forces of this one, well, it will become much more. It will move more to the x direction. All right. So anyway, that's how it works. Now let's keep moving to the next one, tangents. Tangent is pretty much the same, just like the normal. It will based on the tangent direction of the phases to create a force for you. Usually we don't use that. And for the rest part, I would say right now they are not that important. The important thing is this one and the randomized. So, object velocity. What does that mean? It means that if your object moves, it will also affect the movement of the particle. Let's try to do that. So for example, Let's create a keyframe. Press K on your keyboard and set up the location. Then let's go to the frame 20 and move this one to here and press K, location. One more. Let's go to the 50. Or another way is that we can simply using this one, auto can. Once you click this, and let's start to place your animation, and you can see that it will automatically generate the keyframe for you. Alright, but I don't want too many keyframes, so probably I can somehow delete some of them. It's not a very good way to do the animation keyframe because it will generate too many useless information. Alright, so now let's turn off this one, and I want to increase the number of object velocity. So let's play. So see, it will affect the particle movement because right now we have turned on the object velocity. If we turn off this one, well, it doesn't matter. But if we increase, well, you can see the movement of the particle has been changed. So that's how it works. For sure, we still can increase the number of the randomness. So it will make the movement become much more random, and we will have more unpredictable results. Okay, so that's about the velocity. Now let's keep moving forward. Let's go to rotations. For the rotation part, we have to talk about this part with the viewport display. So right now, okay. So right now, our render object is just like this kind of little point, little sphere, right? But if we want to use another model to replace this little sphere, it is possible. Just like the reference I showed to you, we're using butterfly to replace this little sphere. So that's the things we want to do. So how can we replace the sphere? It's right here, nothing in the viewport display, but here, the render. So if you want to change the customized particle, first things we have to go to render, change the render as to object, right? And now we have to assign an object, so it can be anything. Let's choose a cube, probably this one. Let's press G and move this one far away from our emitter. Let's choose this sphere again. And then let's go to render, object, and choose the instance object, this one. So now you can see that the particle has become the cube that we have just chosen. So now let's play. But you will see that the cube actually, although they are random particles, but they still keep the same direction and they are not rotating. So if you want to make them rotate, we have to choose this one. That's the function of the rotation. Let's check the rotations. Check the rotation button, and you can increase the randomized options. So now let's choose play again. So see, right now they rotate in different directions, right? That's how it works. Also, you can choose dynamic. If you choose a dynamic, the cube will rotate even more. Okay. And also, we can play around with some interesting things. So for example, right now, the angular velocity, it will base on the velocity of the particle. But if you change this one to probably global x, let's increase the number. Let's take a look. The object or the cube, it will base. We can temporarily decrease the power of this one. Otherwise, it's moved too fast. Probably just 10 will be fine. Alright. So see, the object will rotate based on the x directions. or if you want, you can change to another one. So let's go to here, particle, then let's choose in maybe global Z. You can choose in, the amount right now is 100, so it's the maximum number. Now let's see. Okay, something like this. So usually I will keep this like velocity. I think that's the best result. And for amount, probably just keep the maybe around 30 will be fine. So for the rest of things, you can just follow my setting to do the rest setting for your rotation table. Okay, so that's about rotation. So now let's move to the physics. For the physical part, it will be a little bit tricky. So first thing, you can define the method of the geometries. And second thing, I think that's more important, the Browning, drag, and damp. This part is a little bit tricky because not that easy to explain. Anyway, for the Browning, if you increase the number, it will force your particle system move more random. It will have some random Browning movement, just like an atoms or something. So when the, for example, when the water is boiled, the atoms of the water will move randomly, or something like that. So if we increase the number of this one, it will increase the randomness of your particle. And if we increase the number of the drag, let's see what kind of thing will happen. Let's decrease the number of Browning. And also right now, I want to temporarily delete all these pins. Otherwise, it will move too fast. And let's move this one to here. Selection the cursor. Let's increase the number of drag and also increase the number of damping. For the damping, it will create friction forces in the air. So somehow make your particles slow down. Alright? That's how it works. And for the drag, right now it's not that easy to say. Let's take a look. Drag, regular speed down. That's the things I write down right here. So basically, I would say for the drag, it will somehow slow down the force in the end part. So for example, at the very beginning, the speed is very, very fast, but it will make these areas start to slow down. So gradually speed down. So that's how the drag works. If we decrease, basically the speed will be more regular. But if you increase the number right here, you can see when this part come out, when the particle come to here, the speed will going down. And for the drag, I think it's very clear. It will slow down everything. And also right now you can see the power of the dynamic rotations. I think it's too much. Let's decrease. See? All the particles, they will rotate because of that. We check the dynamic. If you decheck that, well, it won't do that. Also, if you check right now, check this one to y directions or to x direction, it will also change the rotation of the geometries. Anyway, right now let's just choose velocity. Okay, so that's about the physics. For the Browning, it will increase the randomness. For the drag, it will slow down the particle in the end part. And for the damp, it will increase the frictions in the air. Okay, so I think right now we have go through all the important part: velocity, rotation, physics. Render is also very important. So now we can go to children. You can increase the number of the particle if you want. If you're choosing none, then the particle will just keep the same number, just like this one. If you're choosing symbol, you can see that every particle will be divided into 10. And for sure, you can control the number. If you want more or code, it will look like this. And if you want less, well, you can choose in 6 or 3, just like that. And for this part, I don't know how it works, but anyway, usually I will just using none and symbol. So final things, a very important setting about the particle emitter, about the force field weight. So right now, as far as I can see, we use the force, that the name of this force field is force. Okay, you can see that now the type of the force is force. For sure, we can turn this one into another different force. There are too many different forces right here. We have the charge. This one is pretty weird, and also we have magnet and Leonard Jones. This one is another physical nouns inside in the physical field. So usually, I think for this part, you can try to play around by yourself, but probably we don't use them that much. Usually, I prefer using turbulence. This one is very powerful. Vortex, wind, and for sure the forces. So let's try to use in turbulence. Alright, so right now the turbulence is so small. Let's try to move that. And we can, this part will be another different important setting because it's more about the setting of the forces. So right now I will just play around with this one and show you how it works, but I will not talk too much about the detail. Alright, let's turn off the children because there are too many particles. It will affect our vision. And also for the forces, let's increase the number. Alright, so now you can see that. For the turbulence, you will create a, I don't know how to say that. It will create a gauge-like force and force all these particles follow the flow of the force to move. Right now, it's still falling down. It's because we still have gravity. So, it's a very important thing to know, guys. In the force field, you can define what kind of force will affect your particle. If you don't want the turbulence affect your particle, you can decrease the number. So see, right now it will just keep falling down. If I increase the number right here, well, the turbulence will affect your particle. And if you don't want to let gravity affect your particle, then just turn off that, and it will look like this. Okay, and if you still have some, and I want this one can be more powerful. So let's go to here, increase the number. Alright, still not very clear, but anyway, that's how it works. Alright, this is the turbulence. It will create a turbulence power right here, and we can. So anyway, that's about the emitter. We can use in the force field to control what kind of power you want to use. You can turn on the gravity or you can turn off the gravity. It's totally up to you. Usually, if I want to have a quick result and I don't want the gravity affect my particle, based on my experience, I will turn off this one. And the effect of the forces will be more clear. Okay, so I would say that's all for the basic setting for the emitter. First thing is emission setting. Second thing is velocity. Third thing is rotation. Fourth thing is physics. And fifth thing is render. And final thing, children and force field. We still miss one thing about the catch. What's the meaning of the catch? Usually, once you finish your setting about your particle system or your physical simulation, we prefer to use in catch. So you can use in click this one or you can choose back all dynamic. It will back all the physical setting inside your Blender file. And for the back, you will only back the one you choose. So right now I want to back this one. So you will start to back and store all the information into your computer. And there will be a new file show up inside your folder. Let's take a look. Let's save as a new file. And let's delete O back because of the position I back is wrong. Let's do that again. Back. Let's see. No, she's still back in the original place. Delete back. Alright, anyway, it doesn't matter. Usually for the new file, it will back in the same place where you store your file. But I guess because this is an old file, so I back the dynamic information into the old places. But it doesn't matter. Anyway, once you back, you will store the movement information of your particle, so you don't have to render every time. For now, it won't take too much of your physical memory, and you are just using the old data to do the simulation. So you can hugely save your computer and physical memory. So usually I will do that once you finish all the setting, and then we can use it back to record the setting of record the movement of the particle. So for the next time, we don't have to do the simulation again. All right. So I think that's all the basic setting about the emitter. And for the forces, I would say there are too many forces we can play around. So I will just choosing one or two, and then let you guys go through that. And also help you understand the basic parameter inside the forces. But for the rest of the part, for example, like the Leonard-Jones and the harmonic, and also probably Boyd, all these kind of forces, they are a little bit tricky, and they have different way to do the operations. So I would say play around with them, and you can get used to that. But anyway, I will still help you to understand the basic setting about all these forces. Alright, so that's all for today. Thank you for watching. See you next time.